The point of this demonstration is really to look behind some of the complexity of a decision-making system such as the one we've worked through with the goal and also some of the other discussions we've had. When we've talked about the goal in Alex's circumstance, we really look at only three, four, five, six different variables or areas that material passes through. But we have to realize that in a manufacturing environment, we're talking about a very dynamic and robust system that's highly complex and difficult. The way we deal with this normally in a manufacturing environment is with a process called material requirements planning and a bill of materials referred to as a BOM. Generally, you may have seen this as part of an operation management or a management science course, but I wanted to just really quickly go through to discuss this. And for instance, we're in a program called QM for Excel, easy download. You can get it from actually onto every computer, including a Mac. But we're gonna click on actually go chapter by chapter. We'll alphabetical. Click on operation management approaches and click on MRP or material requirements planning. I won't title this, but to begin, we're looking at a situation, and I will make sure that I post the outcome here. But basically, we're looking at a problem with 6 lines, and or I should say 6 different systems. And we're also looking at 6 periods, let's say days, weeks, months, whatever. And we'll name that period. Click OK. And so it'll actually line this up for you in QM for Excel. And our first one is BOM or Bill of Materials P. And there's only one parent to that. And that's our primary here, so we don't need to outdent or indent that. The next one is bill of material item A. And again, this can be from any process as we're developing the tree for that. Again, take a look at your materials provided, and that will provide the tree diagram for this MRP. Our next one is C, and that actually needs to be subordinated to A. Okay, our next one is B. Okay, and that needs to be, no, it's not the same level. It's the same level as A. And then we've got item, again, item C, and that needs to be indented. And then the last one is item D. And there are actually 2 parents usage on this. And that needs to be subordinated, as you can see, at the same level as C. Generally, we're done. And we close that out. And as you can see, because of that diagram that we created, it has developed this, this tree approach. It's set it all up for us. And now you can see every one of these different stations. Now we have to produce at the front end of this 400 units. And again, look at the materials for that. By 6, we need 400 units. Our lead time is going to be 1. 1 day, 1 week, 1 month, probably 1 day. And that's pretty much it. There's no currently anything on hand. So we're in good shape there. So we go to our next one. Lead time is 1 day. We have inventory on hand. We've got 100 units. And you can see we're what's called exploding the BOM to develop the material that we need to develop. There's a 1 week or 1 day lead time, so we've got to have it for period 5. We've already got 100 units available, so we need to produce 300. We have a 1 day lead time, so we've got to provide that by day 4. And we could have labeled this up front. Okay, our next item is B. Okay, now B, actually it's got a minimum order quantity of 450. So we have to make 450. Currently nothing on hand and a lead time of 1. Okay, number C, we have 90 on hand. So that's going to change that out. We've got, in week 2, we've got scheduled receipt of 100 of these items. And the fixed order quantity is 600, so we have to make 600 at a time. That's just the way our equipment works. Okay, now D. Let's see, D right down here is our last item. Okay, item on hand, we've got, you're going to have to trust me on this. I think it's below our screen. Unfortunately, let me see if I can drop that down. I can. There. So there, 50 on hand. Schedule receipt in week 2 is 80 of these. Okay, and the lead time is 2 days. That's going to jet that all in for us. And really, that should be it for our MRP. And we've got that all set up as an opportunity. Now, all of a sudden, you can really begin to appreciate that it's more than cups or plates with chips in them, or even a bunch of Boy Scouts moving across and, holding hands to reverse the process. When you're looking at these huge and complex systems, and again, this is a relatively simple one, you could actually have a MRP with literally hundreds, if not thousands of different items. And let's say we're manufacturing a high-tech piece of equipment, a computer, a cell phone, whatnot. There are all kinds of different components that have to be pre-manufactured, have to come in via supply, and all of those create their own complexities, their own statistical fluctuations, and lastly, and most importantly, a dependent effect. So when something happens at the very early part of the system or process, it has implications the whole way down through to the very end. I hope this was a benefit. Thank you very much.